All right, we are dealing with continuing to analyze graphs and functions. Today, what I'd like you to do is we're going to take a look at this function right here, 2x cubed minus x squared minus 3x. When it says use the graph of each function to find its y-intercept and zeros, what it's asking you to find is where does it touch the y-axis. Okay, so we're going to find the y-intercept. And then we're going to find where are the zeros located. Now there's other words to describe zeros. One of them you might see, they might ask you for its roots. Or they might say, hey, what are the solutions of this function? Alright? Or they might make it really easy and say, what are the x-intercepts? But usually they really ask for the x-intercepts. But Emily, if I ask you, what are the x-intercepts? And then Bailey, I said, Bailey, what are the zeros? And I said, Jade, what are the roots? And I was like, Dylan, what are the solutions? I'm actually asking you the exact same question, just using different words. Okay? So how many zeros, roots, or solutions do we have in this particular one? Looks like I have one right there, and right there. So all of these mean where they cross the x-axis. How many places does this graph cross the x-axis? 3. All right? So what's the ordered pair for this one? Negative 1? 0. And what's right there? 0, 0. All right. Good. And if you had to put money on it, what do you think would go there? If you had to put money. What point? I like it. 1.50. Now, the y-intercept is where it touches the y-axis. So where do you guys see the y-intercept in this particular case? It's also 0, 0. So interestingly enough, this graph has a 0 at 0, 0, and its y-intercept is at 0, 0, all at the same time. So sometimes they share that in common. Now let's use our graphing calculator. Let's check this out. Take your graphing calculator, turn it on, go to second zoom, and turn your grid line on, if you would. Please turn your grid line on. Okay? And we're going to hit y equals 2x to the third power. And Emily, what's it after that?
Minus x squared.
Minus x squared. And then minus 3x? Okay. Now, what I want you to do is I want you, after you type that in, hit zoom and then the number 4. And it makes a nice, neat graph. And you guys can see that this graph is exactly what you see on your paper. There are all the zeros. There's the 0 and the y-intercept. And there's that point right there. Now, Bailey mentioned something yesterday that's kind of cool. She said, you can ask the graphing calculator where to start your table. So we're going to go over here. We're going to do what Bailey did yesterday. We're going to hit second window. And we're going to go over here to the independent, which is your x, your domain. You're going to go over here to ask, and you're going to press enter. So it's second graph. And now we're going to ask, I wonder what the y value is for 1.5. Because Dylan, you said you thought it was that was a 0 at 1.5. So we're going to press enter, and we'll rewrite it. We were right. At 1.5 it was at 0. What was one of our other zeros?
0.
Alright, so check it. We were right. What's the last one?
Negative 1.
There they are. So you could check to see if you did in fact find the 0, you could plug it in and not have to search all through the table. And that's all thanks to Bailey. Alright. Now, if we wanted to go back, second window, go back to auto. If you go back to the auto, now if you check your table, it has everything listed. Okay? Now, if we want to check it differently, we could also check it by starting our table at 1.5. So if you wanted to start your table at 1.5, you could also do it that way. and there's 1.50. Okay? So just knowing how to use the graphing calculator and its use certainly helps you. Okay? Now, what we're going to do next, everybody, is what if we didn't have a graphing calculator, we didn't have a graph, and all they gave us was this, with note, and then you weren't allowed to use a calculator. Could we still find the zeros? So here's what I want you guys to do in your journal. We're going to find these values algebraically. So I'm going to show you guys how to find this algebraically without the use of a graphing calculator. So we're going to go down here. We're going to find this algebraically. So in your journal, here's what I want you to write. F of x equals 2x cubed minus x squared minus 3x. All right. Now, 2x cubed minus x squared minus 3x, what factor do each of these terms have in common? X. So what I'd like you to do, step number one, I want you guys to factor out the x out of this algebraic expression right here. Factor out the x. Okay? If we factor out the x, let's see what we have left. If I take away, not take away, but factor out an x, I don't want you to think minus, I want you to think multiply. We're going to have 2x squared, because x times 2x squared is 2x cubed. If I factor out an x out of an x squared, I should have 1x remaining. Because x multiplied times a negative x is a negative x squared. And finally, if we factor out an x out of a negative 3x, you're left with just a minus 3. Now, what number could I plug in right there for x to make everything equal to 0? 0. There's one of my solutions. If you take a 0 right here, if you take a 0 and you put a 0 here, guess what? Any number times 0 is 0. So if I put a 0 here, no matter what is inside this, what's everything going to equal no matter what? 0. That's one of my answers. Now, this is where students will forget how to do something. They'll forget how to factor. Okay? And factoring is very important, knowing how to factor. So, where do we start? First place that I always look is I always look right up front. And what number do we see right up front right here? We don't see a yawn, we see a 2. Okay. So, I want you to think of the factors of 2. Just 2 times 1. And what are the factors of x squared? Just x times x. So here's what you're going to do. You're going to put a 2x right here, and you're going to put an x right there. Using the FOIL method, what is 2x times an x? What's that going to give us? It's going to get us back to 2x squared. So that's okay. We're doing everything correctly. Checking our work using the FOIL method. Step number 2. Next thing I'm going to look for is the factors of the very last number, this constant right here. I'm going to look for that factor. So the factors of 3. That's easy. That's just 3 and 1. The problem is where do I put the 3 and the 1? Do I put a 3 and a 1? Or do I put a 1 and a 3? So you have to figure out which one's going to work. Now, how do you figure that out? It all depends on something very important. Put a star right here. It's all about, in the FOIL method, if I say the FOIL method, it's all about the outside and the inside term, the sum of those. That's what we're looking for. So what is the sum of our outside and inside term going to be in our problem? It's going to end up being a negative x. So what I'm looking for is I need to have that be a negative x value. Now I'm going to highlight the outside and the inside. So here we go. The outside is going to be from this 2x to a number, and the inside is going to be from right here multiplied to the x. So we got to figure out what number is going to go here and what number is going to go here. All right. So Raymond, you think you have the numbers? You can put the numbers here. We'll see if you're right. What number do you think goes here?
-1.
-1. What number do you think it goes here?
plus 3.
Plus 3. All right, we'll go plus 3. So we're going to check that. Okay? So he said minus 1 plus 3. So here, so what's 2x times 3, Raymond? What's 2x times 3? What does that give us? 6x. And what is negative 1 times x? What does that give us?
Negative.
If we add those together, what do we get? 5x. What do we want? Okay. So that's good. I mean, we tried one. It didn't work. So now we're going to try something different. Okay? So right now, what I'm going to do is I'm going to say, well, that didn't work. We wanted a negative x. So I'm going to erase this right here. Erase this right here. Anybody else want to give it a shot? Good job, Brendan. Sometimes you have to figure out what it is. If it doesn't work, try something else. Anybody else want to try? All right, Emily, what are your ideas here? 3? Okay, how about this? We won't worry about positive or negatives until the very end. Okay? What's 2x times 1? 2x. And what is 3? What is 3 times x? Ooh. And what do we want it to be? We want it to be a negative x. So, what number needs to be negative? What number needs to be positive? So we say 3 is negative, 1's positive, and guess what we just did? We just finished factoring our problem, because now it works, okay? So what's the last thing? Negative 3 times 1 still gets me a negative 3 for that last term. So what we just did, everybody, if you're watching this video, we figured out the correct factors of this problem. So check this out. Here's our final answer. F of x equals x times 2x minus 3 times x plus 1. And we already figured out that 1, 0 right here is the number 0. This one's another easy one. What number plus 1 equals 0? Minus 1. Was that one of our zeros that we found? Yeah. Now this one's where it's kind of tricky. What number could I plug in there multiplied by 2? Take away 3 equals 0. 1 more. Now what if you just automatically don't think, oh, that's 1.5. Here's what you could do. For those of you who are watching the video, or just really going through it. Set this right here equal to 0, and then solve for x. Add 3 to both sides, right? 2x equals 3, then divide both sides by 2, and x equals 3 over 2, which is the same as the decimal of 1.5. So if you're ever unsure of what the 0 is, what do you do inside the parentheses? Set whatever's inside the parentheses equal to 0. Well, this one's really easy to set equal to 0. You could just say x equals 0. I'm going to solve for x. And that's how you can get your 3 answers algebraically. You factor everything out, and then figure out what number plugged in makes this expression, or this equation, equal to 0. All right, what we're going to do is we're going to use this graph right here to answer these 3 questions. We're also going to use our graphing calculator to show you some cool little things you can do to help solve problems. All right? Now, the first one says use the graph to estimate. Cool. All I got to do is estimate the amount of bottled water consumed in 1994. Now, this is years since 1977. So if I take 1994 and I take away 1977 and I subtract it, that's going to end up being what? 17 years since 1977. So if I go over here and estimate 17 years, it's going to put me right pretty close to the 18, but not quite. From here, if you draw up, perfectly nice straight line going up, and then from here, going all the way across over, would you guys agree that that puts pretty much estimating-wise, estimating, if you wrote 3,000 million amounts of gallons of million gallons of bottled water, that would be right. 3,000 million gallons. By the way, 3,000 million gallons is the same as saying 3 billion. So if you put 3,000 million or 3 billion, that is correct for answer A. That's a good estimate. Now it says find what? Find 1994 consumption algebraically. Round to the nearest 10 million gallons. Okay, so what we're going to do, we're going to use our equation. Except this time we're going to use our graphic calculator. Go to y equals. Clear this out. Emily, can you tell me the equation, the function that goes with that particular graph?
9.35 x squared minus 12.7 plus 541.
All right, so right here. And what we're going to do is we are going to evaluate where it is at 17. So in its second window, I'm just going to start the table at 17. Check the table at 17. And at 17, it looks like my number, 3,028. So basically, 3030 was the nearest 10 million. So right here, where it says the nearest 10 million, if I have 3, 0, 2, 8, and I want to round to the nearest 10 million, this right here, I'm just going to put 30. Or if you wanted to go 3.03 billion, that's fine. And then see, it says use the graph to estimate when water consumption was what? 6 billion. Well, that's the same as saying 6,000 million.
So really all you're going to have to do is go over and go down.
Yeah, very good. So you go over here, go over, and then go down. So if you had to guess, if you had to guess how many years since 1977, it would be. Yeah.
24.
Well, you guys do a guess and check. You said 24 point something. Would that round to a 25? 25 years? So about 25 years. So if we add that to 1977, that puts us in the year what? 2002. All right? Good year for you? All right. Now, right now, I want you guys to get your graphing calculators ready to go because we're actually going to make this, we're going to solve it using the graphing calculators. Here's what I want you to do. Look at your table, and we're going to write down x minimum, x maximum, x scale, y minimum, y maximum, and the y scale. Okay? So let's look at your graph right in front of you, and I'll scroll back up so we can take a look at it. All right? Right here. What's the x minimum? Right there. 0. What's the x maximum? What's it going up by? 3's. 0. 30. Scale is 3. They're counting up by 3's. Every single tick mark is a 3. Now let's look at y minimum. Where are we at the y's? 0. What's it go up to? 9,000. What's the scale of your y values? 1,000. So right here for y minimum, put 0. Y maximum, put 9,000. Scale, put 1,000. That's what I want you to do first. Okay? So write those down. Right now you're writing them down. Watch what I do with my graphic calculator. I'm going to go to my window button. Go to your window button right now. For your x minimum, after you hit your window button, hit 0. X maximum, type in a 30. X scale, type in a 3. Y minimum, 0. Y maximum, 9,000. This is very important next. Make sure you change the scale to 1,000. Let's make sure your grid lines, second zoom, make sure your grid lines are on. So when you hit graph, this is what you see. Oh, I need to change my Y scale to 1,000, not 100. That kind of makes a big deal. Come on. There we go. There we go.
Mine is like a really long line.
Okay. It's always important to have x's. Make sure y equals. Make sure you have all of this typed in correctly. All right. If you don't have that typed in correctly, it's going to really affect the way your graph looks. So right here, here's our graph. I'm going to label it real quick. Here we have what? 3, 6, 9, 12, 15. Don't go all the way up. Counting up by threes, right? And here we have, I'm going to say thousands. Ready?
I have I looked over and I have everything testing correctly.
I'm going to have to disagree with you, but I'll pause the video and see if that's indeed correct. Alright, so here we go. We estimated this time, right? We said right here, if we hit the graph, we went down right about there. Well, this time we're actually going to use the calculator to solve that for us. So check this out. Right now, hit y equals. Go down to y2. Type in 6,000. Why don't you? Type in 6,000. Hit graph. Watch that line. Hit your function. The red line should intersect with the blue curve. Alright, now check this out. Wouldn't it be nice to know where this point of intersection is right now? Well, we can find it. Hit second. Trace. Number 5. By the way, I'm going to write the instructions here. Ready? Hit the second button. Hit the trace button. And then you go to dadgum number 5. Which gets you your point of intersection. Okay? Second, trace, number 5. We'll press number 5. Look where my cursor is. It says the first curve is this function. You see it right there? Yes, that is the one I want. The second one is y equals 6,000. Yes, that's what I want. You press enter again. Then it says, ooh, I'm going to guess where this point of intersection. It's going to calculate it using all the information. And voila, there is your point of intersection. And Bailey's going to be really, really, really excited. Because she's like, oh my gosh, I guessed and checked about that answer right there. So what actually is a good estimate? 24.9 years. And we just rounded that to a 25. Well, you did something.
24.8.
Well, 24.85013.
Oh, okay.
All right. So right there, that right there is how many years since 1977 before it hits 6 billion, 6,000 million or 6 billion gallons of water. All right. What I want you to do is use the graphing calculator, use your notes, everything to solve the last problem on your own. Have a good day.